In this lesson, we're going to talk about conic sections, and we're going to start by talking about the parabola. So you've probably seen parabolas before in college algebra, but we're going to look at them a little differently than you may have looked at them then. So a parabola is the set of all points in a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. So we're going to run through a few formulas that are very useful with parabolas, but I think you'll notice as we go through some examples that I tend to take a much more visual approach to this. So I don't think that it's particularly necessary to remember all of these, just kind of have an idea of how they all relate together. So we have two different forms of a equation of a parabola. You have the vertex form and the standard form. And the vertex form is useful because it gives us the vertex in the equation, okay? And just as a reminder, the vertex is kind of that turning point of a parabola. The standard form can also be useful, and we'll see that a little bit later. We also have what's called an axis of symmetry, which is that line that cuts through the center of the parabola. So in the case of, all of the equations on the left side will be for a vertical parabola. So those are parabolas that look like that or like that. And so the axis of symmetry here is going to be some constant value of x, which will just be equal to the x coordinate of the vertex. The vertex will be h and k. To find the focus, we simply have to add this number p to the y-coordinate of the vertex. So our points that define our focus will have the form h, k plus p. And the directrix, since it's the same distance from the vertex as the focus, but just in the opposite direction, we get that the directrix is a line y equal to k minus p. Okay? Now, as you might be able to tell from these little pictures I drew at the top, we're going to have either our parabola opening up or our parabola opening down. So if this 4p number right here, so if 4p is positive, then it opens up. If 4p is negative, then it opens down. And you might remember that from college algebra. We could also have a maximum or a minimum point on our parabola, and if the parabola opens up, I think it's pretty obvious that we would have a minimum, and that's again if 4p is positive, and if 4p is negative, we have a parabola that's opening down, so we'll have a maximum occur. Okay? So those are the case of a vertical parabola. So let's kind of look at a picture to see how all of this relates together. So we'll draw our little coordinate grid. Okay, so this is our y-axis, this is our x-axis. So let's say that we put the vertex at some point in space, right there. And so the focus is going to be some distance p from the vertex. So maybe we say our focus is right there. The directrix will be the same distance, but it will be in the opposite direction. So this is also p right here. Okay? Now, let's go ahead and draw a parabola. Okay, so the axis of symmetry is going to cut that parabola in half. So it's sort of a dotted line that connects your focus and your vertex. Okay, and of course your directrix is going to be a line through that point on the other side of the vertex from the focus. So this is your focus, this is your vertex, this is your directrix. So when we look at the focus, we have sort of this diameter idea that comes into play. So we have some points that are on that same horizontal line as the focus, And so what that line is called is the focal diameter, and we'll talk about that in a little bit. But the distance from the focus to the parabola along that focal diameter is going to be 2p on either side. So what happens is this entire focal diameter here is going to have a length of 4p. Okay? And that will come into play a little bit later. So that is what our vertical parabola looks like. Okay? So now we'll talk about a horizontal parabola. And these can open right or they can open left. Okay, so again, we have our vertex form and our standard form. Notice with these, it's not the x that's being squared, it's the y. So that's really how you can tell which kind of parabola you're dealing with. Just look for whether the x is squared or whether the y is squared. So with horizontal parabolas, a lot of this stuff is just going to be flip-flopped. So because we're dealing with something on its side, the axis of symmetry will be some line y equal to k, which is the y coordinate of the vertex. The vertex will still be h comma k, but now for the focus, we're going to be adding something to the x coordinate because that is where your axis of symmetry is changing. The y is always constant. So the focus this time will be h plus p comma k, and the directrix will be some line of the form x is equal to h minus p. Okay? Now, as I said, this time we could have something that opens right or left. So if 4p is positive, then the parabola opens right. And if 4p is negative, then the parabola opens left. Okay? And in the case of a maximum or a minimum, we don't have that idea with a sideways parabola because, well, there's no highest point on the graph and no lowest point on the graph. Okay? So maybe I should define p at this point. So this variable p that we've been dealing with is the distance from the vertex to the focus, but it's also the distance from the vertex to the directrix. So p turns out to be a really important letter when you're dealing with parabolas. And we also have this idea of the focal diameter. So as I drew in that first picture, we know it has a length of 4p, okay? And another name for the focal diameter is the latus rectum, so you might see that as well in your textbook. So just be familiar with those different names. So now let's draw a picture of our sideways parabola. So again, we have our y-axis and our x-axis. So this time, let's draw our vertex maybe right there. Let's say maybe our focus is there, and I won't worry about labeling all of the p's this time. Hopefully you'll have that idea. So that would be your directrix. So we have focus, vertex, and then we'll have a dotted line for our directrix. Okay? Now, the vertex always opens in the direction of the focus, so this parabola would have to open this way. And then finally, we can connect a dotted line through our focus that intersects the parabola somewhere, and so this would be your focal diameter. Okay, and of course your axis of symmetry would just be that dotted line through those three main points there. So that is your AOS. Okay, so that is the idea of a sideways parabola. Okay, now going along the idea of a latus rectum or a focal diameter, we have this idea of a focal chord, which is basically a line that cuts through the parabola, which contains the focus. So the focal diameter is an example of a specific focal chord that we use a lot. Okay? Now, I guess we'll formally define a latus rectum. So it's the line segment through the focus of a parabola parallel to the axis of symmetry with endpoints on the parabola. Sorry about this. This should not be parallel. This should be perpendicular. Because if you think about our picture, we said that the latus rectum was that focal diameter, and this is making a right angle with that axis of symmetry. Okay, so again, I'm sorry about that. That should be perpendicular, not parallel. All right. And one really important formula that you should know with parabolas is this magic relationship, I like to call it, of 1 equal to 4 times a times p. So you'll notice that a and p are really important numbers when it comes to writing equations of parabolas. So keeping this really simple formula in mind will help you a lot, and we'll see that in a second. Okay, so now that we've done a ton of formulas, let's go on to some examples. So we're going to find the focus, the directrix, and the focal diameter of each parabola, and then we're going to use them to sketch the parabola. So for the first example, we have negative 4x squared is equal to y. So the first thing that I would look at here is, well, what is the vertex? Okay. The vertex here is going to be 0, 0, because notice we have nothing added or subtracted from x, we have nothing added or subtracted from y. So the vertex is going to be 0, 0. And I think for the remainder of this section, we're just going to assume that the vertex is 0, 0 for the most part, and we'll talk about more complicated stuff later in another video. So the vertex is 0, 0. We need to find that letter P. So that is really important because that will tell us where our focus is. So let's do 1 is equal to 4AP. Now, in this equation, if you notice, it is written in vertex form. So we know that A is equal to negative 4 because it's multiplied by x squared. So we can do 1 is equal to 4 times negative 4 times p. 1 is equal to negative 16p, so p must be negative 1 over 16. Okay, so what that tells us is that our focus is located at 0, negative 1 over 16. Okay, and at this point, actually, I would start drawing a picture just so you can think about if you're adding things to the correct coordinate and whatnot. So if we draw our coordinate axes, we have our x-axis, y-axis. Now, if you're looking at this equation, okay, you notice that x is the variable that's squared. So we're dealing with a vertical parabola. It's either going to open up or it's going to open down. Now, because the 4 is negative, we know that it's going to open down. Okay, and we know our vertex is 0, 0, so we could go ahead and draw that in. So if a parabola opens down, we know that the focus must be below the vertex. So I'm just going to draw a point here and label it, label the y coordinate negative 1 over 16. Okay, so if we know that the focus is 0, negative 1 over 16, we know the directrix must be the same distance in the opposite direction. So the directrix must be at positive 1 over 16. So this would be a dotted line at y equals 1 over 16. And it's really important to remember to write that as the equation of a line because you are dealing with a line and not a point. Okay? So now we have really everything we need to draw our picture. So we can draw our parabola opening down. Okay? And the last thing we really need to find are those points that define your focal diameter. So remember, that's the dotted line going through the focus, and we want to see where that intersects the parabola. Okay, so the way that we do this is we look at what the length of the focal diameter is. So the focal diameter will have a length of 4 times p. So we have 4 times 1 over 16, which is 1 over 4. So we know that the entire width of that parabola must be 1/4. But notice what's happening in this picture is that y-axis is cutting the parabola in half. So what we want to do is take half of that focal diameter and put it on one side and half of it and put it on the other side. So what's going to happen is we're going to get 1/8 on the right and negative 1/8 on the left. Okay, so the 2 points that define the focal diameter are going to be positive 1/8, comma, negative 1/16, and negative 1/8, comma, negative 1/16. Okay, so those are the 2 points that define the focal diameter. Okay, now notice in this picture that I have drawn all of these things and labeled them neatly. Okay, that is really important when you're graphing stuff like this because, first of all, I need to know that you know where all of this stuff is. Okay, so it's really important that you try to keep everything in the picture that I'm showing you here. All right, so that means plot your focus, plot the 2 points on the focal diameter, plot the directrix as a dotted line, that kind of stuff, and plot the vertex. But you can just label the vertex. You can use letters to label your points as long as you tell me what those letters mean, okay? If you don't want to label them with ordered pairs. All right, so hopefully that wasn't too confusing. So let's try another example. So now we have 20x minus y squared is equal to 0. Okay, so the first thing that I would do is get this into a form that we recognize. So if you notice, the y squared and x are on the same side of the equation. So what I would do is get that to the other side. So we get y squared is equal to 20x. And so if we solve for x here, we can see that x is equal to 1 over 20 times y squared. So right away, y is the variable that's being squared, so this is going to be a sideways parabola. And we know that it opens right because the number multiplied by y squared is positive. Okay, so we know that it opens right. Okay, so at this point, I would go ahead and just sketch a coordinate plane, and I think that will help us figure out the other stuff we need to find. So we have our x-axis, y-axis. We know once again that the vertex is 0, 0 because we have nothing added to x, nothing added to y. So I'll go over here and say that the vertex is 0, 0. Now, to find the focus, we need to find p. So we can start with our formula. 1 is equal to 4 times a times p. So 1 is equal to 4 times 1 over 20 times p. So 1 is equal to 1/5 times p, and so that means that p is equal to 5. Okay, so if we know the parabola opens right, we know that the focus must be 5 units to the right of the vertex. So we know that the focus is 5, 0. Okay, so that's our focus. The directrix must be 5 units to the left then. So the directrix must be at x equals -5. Okay, so the directrix is x equals -5. So now we can kind of sketch the shape of that parabola. So it's going to look something like this. Okay, now the last thing again that we need to do is just to find those 2 points that define our focal diameter. Okay, so remember that to find the total length of the focal diameter, we just take 4 times a. So the focal diameter will have a length of 4 times 5, which is 20. Okay, so once again, we have the x-axis cutting the parabola in half, so we want to half this distance on either side. So what's going to happen at the top point is we'll get a positive 10, at the bottom point we'll get a negative 10. Okay, and so the 2 points that define our focal diameter will be 5, 10 and 5, -10. Okay, so our 2 points again, 5, 10, 5, -10. Okay, so now we have found everything that we need for this problem. And we've sketched our picture in the process. Okay, so let's move on. So this time, instead of giving us the equation, we have to find the equation. And they're telling us what the focus and the vertex are. So we also want to find the 2 points that define the latus rectum and graph the equation. So once again, even though graph the equation is the last part of the directions, I would actually start by drawing some kind of a graph and putting the information that you're given on the graph, because I think that will help a lot in figuring out the equation. Okay, so let's go ahead and draw a coordinate plane. All right, and so we have our x-axis, y-axis. So we know the vertex is at 0, 0, so that's V. And we know the focus is at 0, 2. So we know that we have some focus up here, and that's at 0, 2. Okay, so right away, we know that this parabola opens upward. Okay, so let's just jot that down, because the parabola must open toward the focus. Okay, so another thing we know is that our letter P is the distance from the vertex to the focus. So P must be equal to 2. Okay. Let's work with the standard form of the equation. So we have x minus h squared is equal to 4p times y minus k squared. Okay, so working in this form, we don't even really need to find a. We're good with just p. So let's sub in what we have. So we have x minus 0 squared is equal to 4 times 2 times y minus 0 squared. And totally simplifying this, sorry, this should not be squared. That's my fault. Okay, so we have x squared is equal to 8 times y. So that is our parabola in standard form. So that is a perfectly good equation, and I would totally accept that. Okay, another way you could have done it is found the variable a and found it in vertex form as well. Okay, so the last thing we need to do is just find the 2 points that define the latus rectum. So let's kind of finish sketching our graph here. So we know our parabola must open up. We know the directrix now must be at -2 because the focus was at +2. So this is -2. Okay? So let's think. So our focal diameter is again that focal chord that cuts through F. Okay. So let's find those 2 points. So we know that the total distance of the latus rectum will be 4p, which is 4 times 2, which is 8. Okay, so since our vertex is at 0, 0, we just want to split that distance on either side, and so we get +4 and -4. So this point is going to be 4, 2, and this point is going to be -4, 2. Okay, so those are your 2 points that define the focal diameter or the latus rectum. Okay, let's look at another example. So this time we're being given the focus and the directrix. We're not given the vertex, so we need to find all of that. So again, let's start with a picture and put in what we're given. So we have the focus at 0, -1. So that's going to be down here. That's F. The directrix will be at y equals 1. So that's going to be up here. And we'll have a dotted line going through that point. So that's the directrix. Okay, and I'll just label that a 1. So the vertex must be the point in the middle of these two. So if the focus is at -1 and the directrix is at 1, the vertex must be at 0. So the vertex is going to be at 0, 0. Okay, so now we know that this parabola opens down because it must open in the direction of focus. So we get a parabola that looks like that. So the last thing that we need to do is just find those points that define our focal diameter. So we need to figure out what P is. Well, the distance between the vertex and the focus is 1. So P is equal to 1. Okay, so the diameter of the parabola, so the focal diameter, is 4 times p, which is 4 times 1, which is 4. Okay, once again, this is going to be split into both sides of the parabola, so we get a distance of 2 on the right and a distance of -2 on the left, because that'll give us a total distance of 4. So the points that define our focal diameter will be 2, -1, and -2, -1. Okay, and that's all there is to it. So you see how we're drawing this picture as we're solving the problem. I think that that's the best way to do it, but if you like to use formulas, that's fine. You're welcome to do all of that instead, but I think pictures are easier. Okay, so equation for this one, let's work with our standard form again. So we have x squared is equal to 4py, because we're dealing with an up and down parabola. We know that p is 1, so we can just say that it's x squared times 4 times 1 times y, but we know that this is going to open down, so we need to include a negative sign in there. So the equation of our parabola is x squared is equal to -4 times y. Okay, so now let's move on to part C. So this time we're being given the vertex at 0, 0. The axis of symmetry is the x-axis, and it contains the point 2, 3. So again, let's draw a picture. So we have x-axis, y-axis. They told us this time that the vertex is at 0, 0. The axis of symmetry is the x-axis, so I'm going to go ahead and darken this a little more. So now we know we're dealing with a sideways parabola, because that axis of symmetry has to cut the parabola in half. And we also know that it contains the point 2, 3. So we have 2, 3 up there. And so because it contains the point 2, 3, the parabola must open to the right. Okay? All right. So let's see what we can do with this. So let's start with the general standard form of our parabola. So this time we're going to have y squared is equal to 4p times x. Okay? Now, you might be wondering, well, how do we find p? Okay? Well, this time we're given an x and we're given a y. So rather than being given the focus and just counting, this time we're actually going to have to solve for what p is. So let's plug in the coordinates from our point. We have 3 squared is equal to 4 times p times 2, which gives us that 9 is equal to 8 times p. And so 9 divided by 8 is equal to p. Okay? So our focus then must be 9/8 away from V. So the focus must be somewhere over here. Actually, that's a little too far. So let's say that the focus is like right there. And so the focus is going to have to be 9/8, 0. Okay? Let's see what else we could do. Oh, we have to find the equation. Yes. So to find the equation, since we found p, we can just plug it back in. So we have y squared is equal to 4px, and we just need to plug in p. So y squared is 4 times 9/8 times x, and if we multiply 4 times 9/8, we get that y squared is equal to 9/2 times x. So that is the equation of our parabola. Okay? Now that we found the equation, we just really need to finish our picture. Okay, so we know the focus is 9/8 to the right of V, so we know the directrix must be 9/8 to the left of V, and so we can draw in that little dotted line and label it directrix, and so we know the directrix is x equal to -9/8. Okay, so the last thing we need to find are just those 2 points that define the focal diameter. So let's find the total distance of the focal diameter. So the latus rectum is going to be 4 times p, which is 4 times 9/8, which is again 9/2. So we want to divide this in half to get our 2 points. So the distance on the top is going to be 9 over 4, and the distance on the bottom is going to be negative 9 over 4. And so our 2 points are going to be 9/8, comma 9 over 4, and 9/8, comma negative 9 over 4. And that is our picture. Okay, so again, if you want to label things in your picture with letters, just make sure that you write the actual coordinate point or the equation of the line off to the side, just so I can make sure that you know specifically where they're supposed to go. Okay, so we'll do one last example in this video. We're going to find the vertex, focus, and directrix of the parabola and sketch the graph. But notice this time we don't have the parabola in a nice, neat form that tells us the vertex. So we need to get it into that form. And if you remember doing circles in Math 113 and changing the form of that equation, this is really similar, okay? So the first thing we want to do is move all of our constant terms to the right side and group together all of our variables. Okay, so we get something that looks like that. Now, notice that this y squared has a negative, okay? So what I want to do is factor out that negative from everything that has a y in it. So we get 4x minus y squared plus 2y equals 33. And I'm leaving a space here because we're going to need to add a special number to complete the square. So the way we get this number is we look at the number next to the linear term, or the term where the variable is raised to the first power, and so in this case we would take 2, we would divide it by 2, and we would square that. So 2 divided by 2 is 1, and 1 squared is just 1. So the number we're going to add inside the parentheses is a positive 1. Okay? Now because we factored out a negative, we're actually adding a negative 1 to this entire equation, so we have to do the same thing on the right side. So that is the one place where a lot of people mess up with completing the square, is remembering to add that number to the other side. So make sure not to forget that, okay? So let's keep simplifying. So we get 4x minus, now if we factor down this trinomial, we get y plus 1 quantity squared is equal to 32. And if we want to put this in standard form, all we need to do is move this y plus 1 squared to the other side, move the 32 to this side, so we get 4x minus 32 is equal to y plus 1 squared. And if we factor out the 4, we get 4 times x minus 8 is equal to y plus 1 squared. Okay, so that is the equation of our parabola in standard form. Okay, so let's see what we can do from here. Well, we can definitely find the vertex. So we know that the vertex is going to be positive 8, comma negative 1. Okay, and that comes from the fact that our standard form equation has negative signs. So basically you just want to switch the sign of whatever your coordinates are in those parentheses. Okay, let's see what else we can find. Well, we know that 4 is equal to 4p, so we know that p is equal to 1. Well, that helps us because now we can find the focus, right? So this is the point where I would start drawing a picture, because we want to make sure that we're putting our focus and directrix in the right direction. Okay, so let's draw a big coordinate axes. So we have our x-axis, y-axis. 8, negative 1 is our vertex, so I'm just going to draw a point in space and label it V. Okay, so we can just say that that's, actually let me draw it closer to the x-axis. Let's put it more right there. Okay, so that's our point V. Now, we don't have a negative next to 4, so we know that this must open to the right. Okay, so when we find our focus, we're going to be adding to the x coordinate, okay? Because if you notice, that dotted line I just drew is our axis of symmetry, so our focus must be somewhere to the right of our vertex, okay? So the focus, we're going to keep the y coordinate, and we're going to add 1 to the x coordinate. So our focus is going to be 9, -1. So I think our focus would be about right there. So our directrix is going to be in the opposite direction. So the directrix will be 1 unit to the left, and we'll have a dotted line at x is equal to 7. So that's directrix, and the directrix is x is equal to 7. Okay? And finally, we just need to, well, we've sketched the graph. We found the focus, we found the vertex, we found the directrix, and that's all we needed to find. Okay, so these are your 3 answers. Okay, and we got that by putting that original equation into standard form. Okay, so those are some basics about parabolas. Next time we'll start talking about ellipses. And so just start working on a little bit of the homework, and that homework is listed at the very end of the notes for this section.